Hey everyone, so in today's video we're going to go over the definition of a derivative. So a derivative simply measures the instantaneous rate of change of a function at a point. So using first principles, the derivative of f of x is defined as the limit as h approaches 0 for f times x plus h minus f of x all over h. So with that said, let's go over our first example. So let's say I were to tell you to find the derivative of f of x is equal to x squared. So what would you do? Simply you'd have to plug that into this equation. So in order to do that, we would go f prime of x, so the derivative of f of x is equal to the limit, as h approaches 0 of x plus h squared minus x squared all over h, and then we would expand the numerator out. So then we would have this equal to the limit as h approaches 0, and it would be x squared plus 2xh plus h squared minus x squared all over h. And then from here we would simplify. So then it would be equal to the limit as h approaches 0 for 2xh plus h squared all over h. And then from here we would factor out the h. So we would have it essentially be equal to the limit as h approaches 0 for 2x plus h. And then if we were to apply 0 for the h, the derivative would simply be 2x. So that means that the derivative of x squared is equal to 2x. So let's try another example. Let's say that for this here, I were to give you a question saying find the derivative of f of x is equal to, let's say, 3x plus 5. So for this here, once again, we need to plug it into the equation. So f prime of x is going to be equal to the limit as h approaches 0 for 3 times x plus h plus 5 minus 3x plus 5 in brackets all over h. And so from here, we're going to simplify the numerator. So this is going to be equal to the limit as h approaches 0 for 3x plus 3h plus 5 minus 3x minus 5 all over h. And then from here, we're going to be left with the limit as h approaches 0 for 3h over h. And when we apply 0 for h, we're simply left with 3. So the derivative of 3x plus 5 is equal to 3. So let's try one last problem together. Let's say I were to give you, I told you to find the derivative of f of x is equal to the square root of x when x is equal to 4. So with that in mind, once again, let's plug it into our equation. We're going to do it a little bit differently now, though. It's instead of f prime of x, it's going to be f prime of 4 is going to be equal to the limit as h approaches 0 for the square root of 4 plus h minus the square root of 4 all over h. And so now we need to multiply the top and bottom by the conjugate to try and simplify those square root signs. So it's going to be the limit as h approaches 0 for the square root of 4 plus h minus 2 over h times the square root of 4 plus h. Sorry, not minus 2. It's going to be plus 2 over the square root of 4 plus h plus 2. So from here, we're going to be left with this being equal to the limit as h approaches 0 for 4 plus h on top minus 4 all over all over h times the square root of 4 plus h plus 2 on the bottom. And so from here, when this gets simplified, it's going to be equal to the limit as h approaches 0 for h on top over h on the bottom multiplied by the square root of 4 plus h plus 2. And so when we cancel h out of this, we're going to be left with it being equal to the limit as h approaches 0 for 1 over the square root of 4 plus h plus 2. And that's going to be equal to 1 over 2 plus 2 when we apply 0 into the h, which is going to be equal to 1 over 4. So the derivative of the square root of x when x is equal to 4 is equal to 1 over 4. And that's how we show it using this equation. So a few key takeaways to remember. This is the long format or the long way to do it to find the derivative. In future videos, we're going to go over some shortcuts which simplify the process. And the derivative from the first principle is the foundation for all derivative rules. So you need to understand this in order to understand those future shortcuts. I hope this video helped. Thank you.